Good morning, everybody, and welcome to this professional development opportunity from the Maine Department of Education. My name is Joe Schmidt, and I'm the Social Studies Specialist at the department. Today, I am happy to welcome a colleague and friend, Dr. Dean Vesperman from the University of Wisconsin, River Falls. Dean is here to talk to us today about the brain and culturally relevant pedagogy. I've been talking with him about this. He's very excited about this presentation, and I'm happy to tell you that a lot of the people and resources and research that he's going to reference is stuff that I'm aware and familiar with as well, and give that support. This is good stuff that you're about to learn from Dean, who works, he's a professor of education at UW River Falls. So without any further ado, my colleague and good friend, Dean Vesperman.
Joe, thank you for the warm welcome. I'm really excited to see the number of people who are attending today, given the virtual nature of today's presentation. So today we're going to look at the brain and culturally relevant pedagogy. And just so an introduction about myself, I taught social studies for 11 years in Southeast Wisconsin. My master's was in brain-based learning from Cardinal Stritch. My doctorate is from Indiana University. My minor was in the learning sciences. And so very interested in how students and children and adults construct knowledge. And currently I'm teaching social studies methods, elementary and secondary methods, and educational psychology at UW River Falls. So one of the things about brain-based learning is that there's two factors that play into brain-based learning. And the first is that it's heavily influenced by our expansion of our understanding of the human brain and the biological processes of how children and adults construct knowledge in the last 20 years. It is amazing when you begin to read about neuroscience research, how much we have expanded our understanding of the biological aspect of learning. And so it's one of those things that, a good example I always tell my students is when I was an undergrad and getting my licensure in the 90s, we believed at that point, like our prefrontal cortex stopped developing sometime in our early 20s. Well, now we have more knowledge that actually women continue to add neurons into their prefrontal cortex into their mid-20s, men into their 30s. So the other big advance then is they just finished a couple of years ago remapping the cerebral cortex and found that there were new regions of the cerebral cortex that they had yet to map. And so there's some major breakthroughs. The other big breakthrough that's been making is we now have a pretty good idea of the 40 neurotransmitters, those chemicals that the brain creates so we can function. We know what 40 of them, and the little diagram I have up there, we share this with my students. These are the 8 most important for when it comes to learning. And you can find information on all of these. One of the really interesting ones is GABA. It's a really long protein. That's why they shorten it to GABA. It's a calming neurotransmitter, but they have found that it's really directly linked to learning. That when students are learning, that the brain produces more of that protein. And it's really interesting because that protein is also connected to oxytocin. And so, it's interesting then how those two proteins interact with each other. And the other thing that's interesting is we know that when students are producing GABA and oxytocin, they produce less adrenaline. So they're less likely to go in that fight or flight mode. So those neurotransmitters and the knowledge that we have now about the biochemistry of learning is really, really becoming interesting. And then the other area of research then that brain-based learning is built on is the research in cognitive science, artificial intelligence, and information processing. It's interesting that the research done, especially by Seymour Papert in the 60s and 70s into the 80s, he really opened a lot of doors on thinking about different ways of how human beings construct knowledge versus the old behaviorist, cognitivist models of thinking about how children construct knowledge. And so today we're going to really go into information processing a lot because a lot of the current researchers, especially Zaretta Hammond, who we're going to talk about, her work heavily lies on the use of information processing model of thinking. So we'll go through that model. Don't worry, but we'll get to that in a little bit. I want to talk a little bit longer, though, about culturally relevant pedagogy. The term culturally relevant pedagogy was originated by Gloria Ladson Billings. And what she argued is we needed a pedagogy in our schools that empowers students to retain their cultural identity and succeed academically. So she was challenging two prevalent visions of education. One is that students of different cultures need to assimilate into the dominant culture for them to succeed academically. And she also counters the other trend, which is the belief that children should only be taught in their own culture, and that only through that way can they succeed academically. So there's a middle ground that Gloria Ladson-Billings in her work tries to set out. And one of the key aspects of culturally relevant pedagogy is that culture plays a major role in how we construct knowledge. And we're going to talk about that a lot today. But I want you to think about culture and how it plays a role in how we construct knowledge. The one thing we always do as adults is we forget the struggles we had in understanding the external world when we were children, because it's no longer needed. Our brain no longer needs that information from that struggle. And so we forget how important our culture is, how our understanding of the external world plays in when we learn something new. And part of the reason why is because we're older and our brains are more efficient, our minds are more efficient. And so we tap cultural tools that we've learned without even thinking about them. And for children, they don't have that ability, right? And part of the reason why is because they're just not as old as us, right? I mean, I don't know how old everybody else is, but I'm ancient. So in the end, that's one of the key things that we have to keep thinking about then is how does issues of age and how old we are play then into knowledge construction? And one of the key things then is that we use culture then as a lens. And it's we can be conscious of how we use culture. We can be literally, we're using it right now, doing this virtually instead of being in a central place, typically a hotel or a convention center in a room, right? So the culture itself is this key lens that we use to understand the external world. Now, children use culture then to construct this external world, and then we're going to talk about schema. Information processing model likes to borrow the concept of schema from Piaget, in the sense that they believe that schema then are these internal building blocks of knowledge that we construct, and that children are active constructors of knowledge. And of course, then what that means, and of course, is culturally relevant pedagogy then challenges that old transmission model of thinking of teaching and learning, that I can somehow, just by talking at you, and you passively are constructing knowledge. And one of the things that culturally relevant pedagogy works at is challenging that transmission model of learning and changing the focus of learning from the teacher as the imparter of wisdom and knowledge to the student as the active engineer of learning. And that's one of the key things about this. The other role of culture is that we forget as adults sometimes is the role that language plays in knowledge construction. Language is the key medium, and you can ask any sociologist. Sociologists have written treatise upon treatise about this. But language is the key method by which we transmit culture from one generation to the next. It's the main tool we use for explaining the internal and external world. And so for us then, and in culturally relevant pedagogy, there's a heavy emphasis then on language. So what is the language we're using? What is the language our students are using, right? How are we presenting how are we challenging them to use the language? One of the key things I always tell my pre-service teachers, especially the elementary ones, is if we don't teach children the complex language of our discipline, whether it's mathematics, social studies, English, etc., how are they going to be able to explain the world, right? We shouldn't be afraid of teaching our children, as they always like to say, the big words. The other key aspect of language, and this comes from Lisa Delpit's work in culturally relevant pedagogy, is that we need to teach all students how to code switch, how to move between two languages, but in basically teaching them how to construct knowledge both in their vernacular language and in the disciplinary language. and then to be able to move back and forth between those two. And Delpit's work is really key for a lot of the things that I do when I teach, because one of the things that she always stressed is that if we only teach students in one language and not the other, they can't function in the other world. And so one of the things that we have to be always cognizant about is not just teaching students language, but teaching students how to function in both languages. And of course, you know, in her work, a lot of her work, she was based off of then W.E.B. Du Bois's work and his ideas of code switching. And then lastly, the other thing we have to remember, and I always love this, this quote from Zaretta Hammond, is that children cannot leave their culture at the schoolhouse door. We can try and bring them into our classrooms. We can invite them. We can create a warm environment. We can create an environment that is safe for them to be at. But in the end, it's not safe for them if we ask them to leave who they are or who their family is outside of our classroom. So we can't, you know, one of the things, and then, you know, this also goes back into the issue of, you know, one of the things you might hear about is the issue of teachers wanting to be colorblind. Well, you know, it's easy for white teachers to try and be colorblind because our culture is everywhere. We, you know what I mean? We don't have to, you know, we don't worry that when we walk into any room in our school that our culture won't be present. That's not the case for our students of color. That's not the case for our students, our immigrant students. That's not the case for for those students. So we have to keep that in mind, that culture is going, our culture of our students is going to come into our classrooms, whether we wanted to or not. And culturally relevant pedagogy says, look, we got to stop fighting it. Instead of seeing culture as a deficit, we need to see culture as an asset, right? So culturally relevant pedagogy, if you want more, you can always email me. I'll have my email at the end. There's a lot of resources, great stuff out there to help you with this. Now for Zaretta Hammond's work, she looks at culturally relevant pedagogy in the brain and how this works. So now we're going to focus in on Zaretta Hammond's work and start to bring these two worlds together, the brain-based learning and culturally relevant pedagogy. And one of the key things to remember about learning is that learning begins with the external world. Learning begins outside of ourselves with our sensory data. One of the key things we want to think about is that we have three senses we use for complex learning. For even how powerful the scent of smell is, unfortunately, we don't have scratch and sniff textbooks. So it's hard to, you know, trust me, don't even get me started in thinking about a textbook you can lick to learn, right? So really, I mean, when it comes to the senses, there's only three that we use for complex learning. And those are sound, sight, and touch movement, right? You know, auditory, visual, kinesthetic. One of the things that I will warn you is if you believe in those solitary learning styles of auditory, visual, or kinesthetic learning, and that students can be classified at those, be careful. If you go into culturally relevant pedagogy and you start to do the research, they're going to blow that myth out of the water. It's going to sink faster than the Titanic. Because the research on the brain says the brain doesn't choose just one sense for complex learning. The brain processes all five senses. In fact, right now, whether you think about it or not, you know, your brain right now is, I mean, the nerve endings in your mouth are telling you what your mouth tastes like. And that goes on for all of our students then during the day. So those senses don't get shut off, right? But only three of them are really needed for complex learning: sound, sight, touch, and movement. And then this sensory data we have coming in is sorted. The miracle of the brain, and this is one of the reasons why cognitive science and artificial intelligence, and Seymour Papert especially was really interested in how we construct knowledge, is because computers can't sort incoming data. It accepts it all. It can't say which data is important and which data is not. It doesn't have that ability. The very amazing thing about our human brain is that it sorts data. It's getting data right now from all of your nerve endings, from everywhere. It's getting up to the brain, and the brain then is built to sort this. And it has 3 organs to sort data. And the first most important one is the reticular activating system. Now I'm going to talk about the RAS because, you know, this part of the old reptilian brain is so important for learning, and we sometimes forget about how important it is. The RAS, and it's right there on the slide, sleep and awake, fight or flight, motor functions, heart rate, breathing, pain stimulus, and right? And the RAS, its first task is to ignore stimulus you don't need. So a good example is you might forget right now if you're wearing shoes or not. The nerve endings in your feet aren't forgetting that you're wearing shoes. They don't think, right? The nerve endings in your feet, which are pressure, pain, hot, cold. Those nerve endings in your feet are still sending signals up your spinal cord to your brain, right? And it's going, I'm wearing shoes, I'm wearing socks, I'm not wearing shoes, right? And what happens then is it gets up to the RAS, and the RAS says, this is not important, and it just dumps it. So a lot of sensory data gets dumped. And that's one of the key things about this. And I always love talking about this in my ed psych class, because we always have that myth that the brain remembers everything. And that's a huge myth. It doesn't. It's not built to. Right? We have a few, there are people, of course, yes, who have, eidetic memory, things like that. But for the majority of people, the brain is actually built to forget. It's built not to remember. I mean, that's why if I asked you right now, all right, so what did you have for lunch on Monday? Unless you had like a really important lunch with somebody who you care about, or if something happened during lunch that was emotionally important, you might have forgotten what you had for lunch. Because our brain is built to do that. And the RAS is really that big sorting, so that way then the brain can actually focus more on what's really important and not worry about those things. So one of the key things about our current research in neuroscience, there's a lot of new research on the effects of PTSD on the reticular activating system. And why this is important for us as educators is because there's also a lot of new research then on the effects of prolonged poverty, intergenerational trauma on children, and how you can have children as young as 3 or 4 years old who, because of intergenerational trauma or intergenerational poverty or prolonged poverty, homelessness, will be coming into kindergarten classes or pre-K classes and already have PTSD. And we're seeing the articles about those get published all the time, about students who seem to be wild, students who are tearing up classrooms, students who are, acting out violently because of minor triggers. And what we're really seeing biologically is this child probably has PTSD, and they're in their fight or flight mode, right? The other thing to remember for us as teachers is, some of our older students in junior high or high school come to our classrooms. Please note, falling asleep in class could be a flight mechanism due to stress or anxiety. The RAS may be causing the child, right, to flee from whatever the stress and anxiety by pushing them to fall asleep, right? And of course, then, like me as a traditional teacher when I was younger, when I had a student be falling asleep, I would be a little bit more aggressive with them. And of course, that would escalate the situation. Now I know more about the human brain. One of the things I always tell my future teachers is, calmly go to the student, talk to them, don't escalate the situation, because they could be in fight or flight mode. And that might be why they're falling asleep in class. You never know. The next part of our sensory data sorting system is the limbic system. And this is so cool for learning. When I learned about this when I was getting my master's, I'm like, why wasn't I taught this as an undergrad? Because this is so important for learning. The limbic system is right here. These couple of small organs right here. The amygdala and the thalamus. The amygdala are 2 little peanut-sized shaped ones. We have one in each hemisphere. The thalamus and the hypothalamus there. This does, and there, notice, by the way, the pituitary gland is connected to the limbic system. So that very important gland for human growth. It controls hunger, it controls pleasure, it controls arousal, all of those. So this limbic system is so biologically important for learning, more so some days than even the cerebrum. And the reason why is because the limbic system then is the emotional heart of the brain. And it's the key doorway to memory construction, because if you'll notice, and we'll talk about the hippocampus here, this huge organ right here, the hippocampus, is so important for memory construction. And it's one of the key parts of the cerebrum. We'll get to that in a second. But I want you to stop for a second and think this. Information that gets passed from the RAS goes right to the limbic system, right? So once the RAS says, ooh, this sensory data is important, it sends it to the amygdala and thalamus, which we'll talk about in a second, and says, okay, process this, right? Notice this then, the limbic system is about emotion. So how important now is emotion to learning, to knowledge construction? Facts don't mean much if there's nothing tied to it, right? So we can teach, we can teach all the things we want about, the Revolutionary War, but if the child has no emotional connection to the war, what are they going to learn, right? They might learn it for the test, but then of course, then their emotion is tied to the test. And of course, once the test is done, what happens to that knowledge, right? It decays. So when we go and look at those, these two organs then, the amygdala and thalamus then, the amygdala then is the primary organ for initial memory construction. And we're going to find out this is where that initial thinking children do happens, is in the amygdala. And when you think about that, our initial thinking about something occurs in two peanut-sized organs in our two hemispheres, right? Small organs, right? Not as dense as the cerebrum, right? And then the other thing about the amygdala is amygdala controls fear response. So if something gets past the RAS, but the amygdala goes, oh, this isn't good, right? Because it doesn't require an immediate answer, and by immediate we mean within like thousandths of a second. The amygdala then kicks in your fear response. And so one of the key things then to think about, and I always tell my students, is the amygdala doesn't know the difference between a test and a bear. It's not built to. It's built to tell you, holy sugar, something's going to eat me, we need to run, right? Because again, the amygdala isn't that part of the thinking brain up here, prefrontal cortex. That's where we go, oh, no, this is just a social studies test. This is just a geography test. The amygdala doesn't know that. The amygdala doesn't think that way. The amygdala is built to keep us alive if something's coming through the tall grass to eat us, right? And one of the key things then we want to remember then about children is that anxiety increases fear response. It's very popular now in some literature to claim that there isn't anything as test anxiety. Be careful when saying things like that, because, it could be just general anxiety, whatever you want to call it, but we know this, anxiety increases fear response. If the amygdala says it's afraid, it tells the RAS to act, right? And one of the best examples of that from my own teaching was, I had a seventh grader. He had, he had diagnosed with ADHD. And when he didn't take his medications, he was in motion the whole time. The sad thing about it, though, by the way, is he's 12 years old and his parents had decided that it was his responsibility to take his meds. So it's get in the class and it's a test day, and he's the first student in the front corner. He knew his ADHD well enough that when I rearranged the room once and he wasn't in the first seat by the door, he let me know he always sits in the first seat by the door because he needs to be there. So he's in the first seat. I'm a young teacher, so I'm individually handing out tests to each individual student. So I hand him his tests and going up the row, handing to students. I get to about the fourth person in the row, and all I hear is a thump and a rip. And then, like, I stop, look. I see him raising his pencil up again to stab his test to death. And he goes, thump and rip again. And I go, so I stop, I walk up to him and I go, are you okay? And he's honest. He's like, I didn't take my medication today. And so what we really saw was his brain was trying to defend himself from the test by killing it with his pencil. So when we think about this, then the key aspect then of anxiety and how it triggers fear responses and how that leads then to fight or flight is a key aspect then of us knowing how our children's brains are working and how they function. And then the thalamus then develops the more complex emotional responses. So this is where we get the primary emotions of fear, anger, lust, love come out of the thalamus. I always joke with my students when I used to teach high school psychology that on Valentine's Day, don't send a card that says I heart you, send a card that says I thalamus you, because that's accurate, right? And the key thing about the thalamus then is that it starts to sort these sensory data for memory and for consciousness. So it decides, so the iris sends some sensory data up into the limbic system, and it's the thalamus then that decides, okay, this is enough to build a memory from, this isn't important enough to remember, those types of things. And that's why, by the way, all of us done this. How many of you have met someone, talked to them for like 20, 25 minutes, right? Conversation ends, they walk away, you walk away. Not even 3 minutes later, you try and remember the name of the person who you were just talking to, and it's gone, right? You aren't terrible. It's not Alzheimer's. Your thalamus is just saying they weren't important enough to remember. So just, don't tell the person that's what happened, right? That leads to awkward conversations. Out here in the upper Midwest, that's not Wisconsin nice to say that, but there you go. But here's the key thing. We now know from research, 95% of all sensory data gets dumped. The human brain is built to sort the external world and to get rid of what's not important, right? 95% of all sensory data gets dumped, okay? And that's why, by the way, you can always trick your students. We all have that student who wants to go to the bathroom all the time right in the middle of class. This fall, try this. What I used to tell students is, when they would ask in the middle of class and we're doing something, I always say, we're going to be doing this for another 5 minutes. It's really important. Can you wait? And more often than not, the minute you tell somebody that it's really important and ask them to wait, what happens is their bladder is still sending the message, I gotta go, I gotta go. But the RES is saying, not right now. This is why as teachers, if we have really busy days, we might forget to eat lunch, right? Our stomach is still telling us we're hungry, right? But our reticular activating system and our limbic system is more focused on the task at hand and just then dumps that sensory data. And then suddenly when we finish our work, we're like, oh my God, I'm famished, right? So that's one of the key things we want to keep remembering then is our brains are built to forget, not remember, right? So then moving to the cerebrum then, this dome tissue, and it's really, it's really fascinating about this tissue. And I want to point out a few things about the cerebrum here, right? And the first is we saw the hippocampus, and the hippocampus is the primary organ for memory construction. A really cool thing about the hippocampus, it also controls spatial navigation. I want you to think about that for a second. I'm going to stop for a second. I want everybody to think about that for a minute. The primary organ for memory construction also has a key role in spatial navigation. I want you to think about, what does that mean for learning? All right. And does anybody want to just unmute and tell us what you think? I've been talking for a bit now. So what does that mean, that our primary organ for memory construction also controls spatial navigation?
Does our environment have anything to do with when it knows it should be learning stuff?
That's one of the key aspects, yes. Context matters, right? Context really matters. That's why some students have struggled from the physical move of being taught in classrooms to being taught online. We've changed the physical, spatial, right, nature of learning, right? And of course, since our brains are more efficient, we can make that transition faster than some of our children can. Good point, Neil. Who else? What else does this tell you then? Primary memory. Go ahead.
I took a brain-based learning class out of Illinois State a few years ago, and something that I never would have got to is when you're going to be assessing the kids, giving a test, wear the same outfit from the day that you taught that content material, stand in the same place in the room where you delivered that content, and that's what this reminds me of.
Right. One of the things I learned as a young teacher was that I didn't rearrange my seating charts until after a test. Right? One of the things we're learning now is that if students construct knowledge in small groups, we should be assessing in small groups. If we teach them in small groups and then we change how they're being assessed, we're changing the context of the learning. We're changing their spatial, how they constructed knowledge, right? So that's Go ahead.
Oh, sorry. This is reminding me of college and my psychology classes I had to take. I never tested well. Well, I still, I have tests inside of myself, but
right.
The professor, the one thing that stuck in my mind was the professor asked me, what'd you do while you studied? And I'd say, well, I was in my pajamas. I was drinking hot chocolate or drinking whatever. I might be munching on nuts or something. And he'd say, well, don't come in your pajamas, but bring your drink, bring your nuts, bring your snack, and while you're taking your test, eat and drink whatever you were doing. That will help you bring that memory forward.
Right. One of the tricks I used when I was a teacher was when we'd have study time for them to study for tests, I would play Vivaldi's Four Seasons. And then when it came to the day we were having an assessment, that's what music we played during the assessment, was Vivaldi's Four Seasons. So I'm going to move on, but those are all very good points. The next layer of the cerebrum that's important is the corpus callosum. It connects to both hemispheres. This is one of those things then that I want to stress about the corpus callosum is that our two hemispheres are to work simultaneously for learning. There's a lot of old research about right brain and left brain people. A lot of the new research in neuroscience says you're only a right brain or left brain person as if they took out the other hemisphere, right? That both are essential for learning. The corpus callosum is the key aspect to it. Oh, I forgot to add about the hippocampus. One of the things we now know is that Alzheimer's affects the hippocampus. Corpus callosum is really important if we have students who have epilepsy. One of the things then, of course, with epilepsy is that epilepsy, of course, affects the corpus callosum. So you might have students who have epileptic fits where literally they are awake, they're conscious, but whatever is being taught is not being shared across both hemispheres because of the corpus callosum. And then we have the cerebral cortex, which there's a nice image of right there, and that's the thinking brain. And this, of course, handles sensory functions. So we have our primary visual cortex in the back of our head. We've got our primary auditory cortex on the sides, right? Taste and smell are handled in in this area here, right? One of the key things then about the brain now is that new neuroscience, we now know more about language centers. And we have 4 of them, 2 on both sides. I want to talk about those because that's a key aspect then of why language and culture are so important to learning, right? Because these 2 regions, Wernicke's region, which is in the back of the brain, is for language comprehension. And notice, by the way, Wernicke's area then is tied to 3 areas: the visual cortex, auditory cortex, and this up here then is our automated motor cortex right here. So one of the key things then think about then is for language comprehension, understanding language is about seeing it, hearing it, and doing it, right? So it's about sight, sound, and motor, okay? The other major area then is Broca's, which is up here in the front. And notice the Broca's region for language is connected to our auditory cortex, the prefrontal cortex where we do most of our thinking, right? This is our cognitive brain up here. And then the primary, right, and our other motor cortex, right? One of the key things we now know about dyslexia, dysgraphia, dyscalculia is that those neurological issues affect either the Wernicke's or Broca's regions or both. But that's how important language is then to learning, is we've got 4 of these regions, and it's really important to note Wernicke's and Broca's they're not touching each other. So you can have a student who's really, understands what you're saying, they can communicate with you orally, but if you ask them to write about it and they struggle, it could be the case that, they're really good at language comprehension, but they're struggling with language production, right? But of course, all of our research knows then what the key thing is, don't have them write less. You want them to write more because they aren't going to build neurons if they're writing less. And then we have our primary motor functions. And this is so cool when you think about this. This top half of our cerebrum here is all motor, right? Whether it's automated motor, right? The primary somatosensory cortex ties motor and emotion together. The primary motor cortex here. And notice how important the motor cortex is right next to the thinking, right? Right? This is important. So I want you to think about then, how important is movement to learning, right? So I want you to keep thinking about that. And then of course we have our cognitive functions. We have our prefrontal cortex, frontal cortex, our creative brain, mathematical brain. This is where we have our higher level emotions, right? This is where we do our, attention. All of those things then are in this, right here in this frontal cortex and the prefrontal cortex. Very important. So then so we know biologically how we're constructing knowledge. Oh, one thing I almost forgot. One thing I always want to remember, if you're going to tell your students this, please let them know you don't store knowledge physically in your brain in one place. Knowledge is actually scattered through multiple millions of neural pathways throughout the brain. Excuse me. So let's look at information processing model. And then I'm going to show you a memory system. This is from Wolf and Hammond. Patricia Wolf, she wrote a very good book. It's called Mind Matters. An excellent book about information processing model and memory systems and how we as teachers can use it. Hammond, in her work on culturally relevant pedagogy, has taken that model and advanced it, adding culture then. I want to run through the 4 steps. I want to go through a few things to see how this system works. One of the things that happens then is the human brain takes in sensory data, and we decode the world around us. And again, remember, we want an important role of culture then in decoding the world. And of course, then physically, this is our RAS and our limbic system, right? The key thing about sensory data sensory data gets processed so quickly now that we're older. I mean, it's right. Only a few times a day, I don't know, a few times a day. There are only a few times when we see something so unique, we stop and go, whoa. Right? On the other hand, though, my 20-month-old daughter, every day, there's like hundreds of whoa moments. Right? Because, of course, right, we're using our accumulated cultural knowledge to see the external world, and we process it. We're not, the world just doesn't catch us the way it did. When that happens, then it gets processed into short-term memory. A couple of key things about short-term memory. The average person can only keep about 5 to 7 items in short-term memory. It lasts about 18 to 30 seconds. Here's where emotion comes into play in our short-term memory. And of course, this is our limbic system, which means then if we want our students engaged with something, this is why we have those lessons we teach, and it just has that really powerful hook. And we start the hook, and students just get engaged, and we see them lean forward. We see them, their eyes open, right? They just start to smile. What we're really seeing then is that the role of culture and that emotional response, and how important emotion is then what's tied to our short-term memory. Key thing to remember about short-term memory is after about that 18 to 30 seconds, the human brain just starts dumping things, and it doesn't dump things in order of how things were taught. So, and that becomes interesting because when we teach children, if we move too fast, that can lead to the construction of misconceptions in short-term memory. If something is important enough, it gets past short-term memory and gets into working memory. Working memory is really important because this is where we do our thinking. This is our prefrontal cortex at work. One of the key things the research from information processing has taught us is that students can only keep to about 5 or 9 cognitive tasks. Don't confuse that with multitasking, right? One of the things I always tell my students is, if you think about having your students write a paragraph, how many cognitive tasks does that require? Well, they have to remember, so the students always start with, they have to remember information, and then they have to write sentences, and they have to know paragraph structure. And I'm like, well, go even deeper then, right? For students who are English learners, they have to then also access phonemic awareness and graphemic awareness, right? So not just how to write the letters, but how the letters sound in English, right? And you start running down a list of all the cognitive tasks it takes just to write a paragraph. And then it's easy to understand why sometimes when we give a task to students, if it's too many new things for them to do, they won't be able to do it. A key term at this, when working memory, we talk about is cognitive load. How much can a student have going on at once in their in the working memory, and then once that's full up, right? It's not an infinite amount of space in working memory. Then they hit cognitive load. One of the key things that Zoretta Hammond writes about is when that cognitive load is full is when we'll see students move from productive struggle, which we want them in, to unproductive struggle. Right? That's why one of the key things, if you go deeper into this, how important planning scaffolds are, watching students, and when they see them do that switch from productive to unproductive struggle, how do we come in and give them the scaffold they need to move them back to productive struggle, right? So how do we ease that cognitive load? There are 4 key processes in working memory for memory construction, and this comes from Wolf. And those are elaboration, manipulation, organization, rehearsal. Her research on information processing finds that when teachers have students manipulate what they've learned, elaborate on what they've learned, organize it, or rehearse it, it strengthens memory retention. And then, right? So the 4 key processes, again, are manipulate, organize, elaborate, rehearse. Right? That's one of the reasons why when I was a teacher, I had my students do homework And when parents would ask about why they did homework, I was able to describe to them, well, this homework was for rehearsal. This homework was for them to organize their ideas. This homework is for them to elaborate on what they've learned or to manipulate what they've learned, things like that. But Wolf's done so much great work on those 4 cognitive processes and how essential. If you read Zoretta Hammond's work, she calls it chunking and chewing, right? She puts organization as chunking, and then manipulation, elaboration, and rehearsal as chewing, right? We want them to chunk what they've learned and chew on what they've learned, right? And then finally, long-term memory. This is just our library. We don't really think in our long-term memory. This is just where we store stuff. And from Wolf's work, she described that we have two places in long-term memory. We have declarative memory, which is for facts, and we have procedural memory on how we do something. And one of the things in her work she wrote about was how important it was for us as teachers to focus on the fact that we might have students who have really strong declarative memory, but they could be weak in procedural memory. So they can talk to you about what they've learned in detail, in depth. But if you ask them to do something procedural with it, they might struggle. So we want to look at it then as if they're struggling with some task, it could be a gap in something. So they might be really strong at writing, but they don't, they didn't construct that declarative memory well enough, that schema for what facts you were teaching, things like that. So one of the key things then that comes out of this system then is the idea that wrong answers get constructed. Students build wrong answers. They're thinking. It's our job to figure out where those misconceptions came from so we can help them reconstruct what they, what they missed, what they didn't learn, right? But that's one of the key things when I learned about Wolf in 2004 in her work in Mind Matters, was the amount that she stressed that wrong answers are great because it tells us the child is thinking, but more importantly, it lets us look at where the wrong answer came from, how it got constructed, so we can go back in and help them build a more efficient model of learning. Wolf argues then that, look, learning is about expanding capacity and speed. We're smarter than our kids because our memory system is better. We're older. We've used it more. And then the other thing about it is schema construction, and Wolf and Hammond stress this, is that new schema is constructed on existing schema. So you can do a great job teaching something new to your students, but if there's a misconception or a gap in the existing schema they have, whatever's taught new is not going to, they're not going to have a full conception of it because of that gap, because of that misconception. And so one of the things I always work with my new teachers on, and I did this when I taught, was whenever students would have wrong answers, I would celebrate wrong answers. Because wrong answers meant the student was thinking. They were trying to explain the external world. They were trying to construct new knowledge. And it allowed us then to go back and go, okay, so let's look at what these answers are, look at how this got constructed. So this is the information processing model. So then Hammond then, using those two models, culturally relevant pedagogy, information processing, has 6 key rules to our teaching. And the first is that the brain is built to minimize threats and maximize opportunities to connect with others. Children want to socialize because through socialization, they construct a better understanding of the world. 2, we want to make sure that our classrooms are personally safe, physically safe, and culturally safe. Because if they're not physically safe, it harms children's ability to learn. If they're not personally safe, same thing. And if they're not culturally safe, we can cause children to disconnect from, we could be the greatest teacher in the world, but if their classroom isn't culturally safe, they aren't going to learn. Positive relationships help keep that threat system in the RAS and the amygdala calm. Keeps the amygdala and the RAS from hijacking the brain. enough research, and we've all seen those videos about the elementary student teachers who like greet their students and each student has a handshake and or every, right, those types of things. I'm not saying we have to do that, right? Some of us aren't built for it. Lord knows I can't even remember one handshake, let alone 20, let alone when I was teaching high school 100. But it's the key thing about children need to feel like they're welcome and they're safe. And of course, this is tied to Maslow's hierarchy, right? One of the myths that gets taught is that children who are suffering trauma can't learn. That's false. They can, but it's even more important for children who are suffering trauma to have a very positive relationship and a positive classroom. A key thing about positive classrooms, and if you read Hammond's work, please realize positive classroom doesn't mean that you don't correct the child. If they're doing something wrong, you got to be a warm demander. You have to have high expectations for them. But what it means is that it's safe for them to struggle and to fail in your classroom. And then, of course, we could go into, I mean, I could go for days about how that connects to Carol Dweck's growth mindset. Like what Dweck argues is that fail is just the first attempt at learning, right? Culture guides the process, how we process the external world. Culture is our lens. As being a white person, it's easy for me. As being a white male, it's really easy for me. My culture is dominant. My culture is everywhere, right? I don't even have to be aware of my cultural lens and how I process when I process information. That's not the same for our children of color. It's not the same for our immigrant children. It's not the same for our children, of different gender, sexual orientation, etc. Attention drives learning. We all know this. If the student's not engaged, they're not learning. All new information has to be connected to existing funds of knowledge. Now, please note, existing funds of knowledge doesn't mean that it has to be tied, everything has to be tied to the child's home culture. It means also then that what we teach that's new has to be connected to what they've known, what they've constructed, has to be connected to a schema they've constructed, right? And then 6, the brain only grows physically if it's challenged and stretched, right? One of the key things that we always work on is how do we make sure we challenge students, scaffold their learning so that they can grow? If we give students tasks which are easy, they aren't going to grow. And that's just the thing. And if you're looking at more interesting things or methods on how to design classrooms for challenge, the zone of proximal development, a great model for how we create environments for challenging students. I want to go through a couple things to remember for today. The inner brain does not know the difference between a test and a bear, or a lion, or a tiger. Oh my. Children's brains are hardwired for expansive learning. The minute you're born, they're learning. We now know the old myth that our brain stops adding neurons is false. We're adding neurons all the way until we die. The key thing we now know is that the prefrontal cortex is one of the last areas to really start this expansive learning or expansive growth in neurons. And that over time and eventually that great blooming of neurons in our prefrontal cortex slows down by the time we're in our 20s and 30s. Every child can learn. That doesn't mean that there aren't barriers. We know that we have children who have neurodiversity. We know that we have children who have trauma. We know that we have children who face a lot of other difficulties. They can still learn, but we have to be able to, do things then to help them with those barriers, do those things. The key aspect then is that culture is a lens, and we need to know our students' culture. This is so important for our students. I mean, up here in Upper Midwest, a good example is there's a large Hmong community, there's a large Somali community. One of the things I always take time with my students is to look at culturally, how do Hmong people construct knowledge, and how do Somali people construct knowledge? Because how they look at knowledge is more of a collective vision versus, white American, we tend to view knowledge construction as an individual act. Language is key. We have to work on teaching children, even white children need to be taught the code switch. And Lisa Delpit argues that a lot. All children have intellective capacity, but it only gets constructed through challenge. We have to challenge our students to continue to grow. Culture, I've said this earlier, is not an asset, is an asset, not a deficit. One of the best ones, and I forget the author who said this, we need to see culture as a ladder in our classroom, not a barrier, right? It's something we've used to help them. I always argue then, like I said before, this is strongly connected to Dweck's ideas of growth mindset. And then, one of the key things to remember is because children don't have complex conceptions of culture like us, it doesn't mean that it isn't there. So I want to thank Joe for inviting me to do the professional development today. If you're really interested in Zaretta Hammond's work, the book, some of this was built on this, Culturally Relevant Pedagogy in the Brain, an excellent book. She also has an amazing Facebook website. It's called Ready for Rigor. And she does weekly videos that she posts where she talks about different aspects of things that she's working on, things she's learned, other research. It's just an amazing website if you want to continue to grow as an educator and in culturally relevant pedagogy. And then this is the last time for questions. Here is my email. dean.vesperman@uwrf.edu. If you want more resources or you want to email me a question, if you don't get it asked, we have a little bit of time to answer questions. You can always email me, contact me. I'd be more than willing to share resources with you. And of course, I'm going to be sending the PowerPoint to Joe as soon as we're done, so he'll be able to share this with the video. All right. So we have some time for questions. So if you have questions, let me stop the screen share. There we go. Good.
Does anybody have any questions for Dean? There's some good chatter going on during the session. There was one question. I don't know if you can speak to this at all. I know you don't have the visual up anymore. There was a question about empathy and where is empathy located in the brain?
Right. Mm-hmm. Oh, empathy is so amazing because of the fact that we know that empathy is both in the limbic system and in the prefrontal cortex. So we know that we're actually hardwired to be empathetic, right? So it's already there in our amygdala and our thalamus, but we also know then we use our prefrontal cortex to decide our responses and our empathetic responses. So, but we are hard. That's one of the key things. It's really interesting because on a side note, some research on serial killers is that they found that serial killers' amygdalas and thalamus are smaller than they're supposed to be. And so one of the argument from psychologists is that those undersized amygdala and thalamus is the reason why serial killers don't have an empathetic response. So, but no, we are hardwired for it, but it really starts with our amygdala and thalamus, and then again, the role that prefrontal cortex plays.
Other questions for Dean?
I don't have a question. I just have a comment. It was really interesting, and I enjoyed it because I'm a big psych fan anyways. And it brought up some issues and things that I had learned in psych in college. And I just wanted you to know that you did a very great job presentation. It was awesome.
Thank you. Thank you very much. I appreciate that.
Dr. Vesperman, what would be an example of kind of like a really clear-cut way of including a student's culture in the classroom? Like, what could that look like?
So one of the key things that both Hammond and Nitsa Hidalgo argue is that it begins with the surface culture of students, getting to know aspects of their daily life, food, language, things like that. But then making sure we move beyond that, moving into those deeper levels of culture. So we then move to thinking about, well, how at home do they, how do they construct knowledge with their parents, right? How do they engage in discussion? Those types of things is one of the things that both Hammond and, like I said, Nitsa Hidalgo argue. So a good concrete one to start with is just sitting down with the student and asking them about, their home, about their culture, where they live, those basic things, because it does two things. One, it teaches you about that surface level culture initially, but two, it creates a more positive environment because now the child knows that you care about them, that you want to know more about them, like that. Then it's about making sure that when you're teaching, so like a good example is when I first started learning about this, a good example is, is talking about with my students about, the culture of the Tejanos and Californios in the American Southwest before they became part of the United States. Making sure that they understood, how important then issues like the missionary system was, how important, how that collective sort of communal way of living that the Tejanos and Californios had developed that was more modeled, coming from, Spain versus, what was the American culture like, things like that, having cultural roots. Another thing was, and I still do this now, is when, like a good example is right before, all of this COVID occurred, with my elementary students, we spent some time to look at what Ramadan was, because if they had gone out in the classrooms in St. Paul, there's a large Somali community. So I wanted to make sure that they explored Ramadan so that they knew how to greet their Muslim students. And then two, that they understood what Ramadan really meant and what it really mean, you know what I mean? Because here's a good example, as Christians, I don't know if you're a Christian, but as a Christian, we tend to see Lent as being a time of suffering, right? We're giving things up. Oh, we get a fast on Fridays, blah, blah. And then so then we think about Ramadan and their fasting, and we think, oh, then it's the same thing, but it's not. Ramadan is you fast in celebration, right? So it's about helping us navigate those cultural layers and doing those types of things, right? But it all really starts with talking to your students and asking them questions, right?
Awesome, thank you.
Good. Oh, Jen has a great idea in the chat, right? Having lunch with your students. I did that a lot with my students when I was a teacher. Don't do it as much now as a college professor, but that's it. Other questions?
Well, Dean, on behalf of all of our participants today and myself, thank you for giving up some of your time. I know right before we came on, you had said that you were, all your grades are due tomorrow. So I want to thank you for giving up some of your precious time.
Oh my God, I love this. This energizes me.
Awesome.
This is more fun than grading.